Welcome to Extreme Physics.
A Crash Course in Physics by Erin and Rachel.
Episode 1, Reference Frames and Relative Motion.
Today, our reference frame is Niagara Falls. Notice how the tree, the waterfall, and the cliff do not move in relation to each other. This type of system is called a reference frame.
A reference frame is a group of objects which are stationary and in the vicinity of each other that are used to gauge the motion of another object.
To get her physics thrill today, Erin decided to ride over Niagara Falls in a bucket. In this situation, Erin's motion can be seen in relation to the reference frame. You can see that the bucket's motion, with Erin inside, is falling down. But is she really moving?
Relative motion is the motion of our object in comparison to different reference frames.
Using our reference frame that we talked about earlier, the tree, the waterfall, and the cliff, as Erin rides over the waterfall, she is clearly in motion. Now, change perspectives. Think instead of the bucket as the reference frame. If you do this, Erin is not moving in relation to the bucket. Even though the bucket itself might be in motion, Erin is stationary inside of it. When the reference frame changes, the same object in the same situation can be thought of as having different relative motion. Relative motion depends entirely on the reference frame you choose. To reiterate, when looking at Erin's motion in relation to the reference frame of the tree, the cliff, and the waterfall, she has obvious relative motion. When a narrower reference frame is used, just looking at Erin inside the bucket, she has zero relative motion. This is because Erin is not moving inside the bucket itself. This same concept can be applied to any reference frames you choose. For example, planes, trains, and automobiles. On a greater scale, you can think of yourself in motion in reference to the Earth, but not in reference to the Sun as the Earth orbits around it.